Hello guys, please engage with polls. Hello everyone, welcome to another session of DataHour series. We will start in 5 minutes.
Hi guys, am I audible? Hi Sambhav.
Hello, hi, good evening.
Hello. Good
Good
evening.
evening.
Good evening.
We'll just start in 3 minutes.
Yeah, sure. Meanwhile, let's check whether I am able to share my screen or not.
Sure.
Host disabled participant screen sharing. Can you please give me the access?
Yeah, I gave you that.
Okay. So is it visible? Are you able to see my screen?
Yeah, it is visible.
All right.
Yeah, it's
Oh.
Hello everyone. Welcome to another session in the DataHour series. We are thrilled to be here this evening for a session full of action-packed learning. And I am Avinash Reddy Chikampalli, part of data science team at Analytics Vidhya. For those who have joined for the first time, a brief introduction to the DataHour series. The DataHour is a series of webinars conducted by Analytics Vidhya and led by top industry experts. It is a fun way to understand the concepts of data science from the leading players in the data tech domain. And as the name suggests, it's 1 hour dedicated to data. The data, we are hopeful that these sessions are going to be great source of enrichment and value added to our community members. And now on to our sessions today, which is production in machine learning. The DataHour is going to be hands-on workshop in which we'll walk through building machine learning solutions and thereafter making it productionize using Flask API. We'll develop machine learning APIs from scratch to build the request response system from the MI model. And this webinar also includes the basics of REST API system and how industries are leveraging machine learning using microservices. So I hope you're excited to attend this DataHour with us. And on to our speaker in this session of DataHour, we have Rajan Kumar Yadav with us. And Rajan Yadav is lead data scientist architect at HCL Technologies with 9 years of experience in data science, machine learning, and artificial intelligence. He is an experienced artificial intelligence engineer with a demonstrated history of working in the banking and financial services, healthcare and 5G telecom management industries, and expert in experimentation and applied ML. So previously, he has worked with companies like Cognizant and Mindtree. And over to you, Rajan Yadav. The virtual stage is all yours.
Yeah, thanks for introducing me. Hi guys. So if you are able to see my screen and you are able to see you are able to see the screen, please write yes in chat, and then we will start. All right. So good evening, guys. So let's start. So in this data hour, what we are going to do, we will build a machine learning model. It will be a simple model, and further we will deploy it on any premises, whether the target system will be any cloud, or maybe you can deploy it using on your own laptop. So let's start. So in today era of AI, machine learning, as well as data science, it's very it's very important to the building the data science. You have to also keep in mind that how we can deploy it and how we can make make an application out of it. So we all uses Jupyter notebooks to build model, do exploratory data analysis. So in this session, since time is limit, so I will go through the deployment process more deeply. So how we can build the app, how you can create great app from any data science use cases. So hope everybody is hello Ankit. Yes, so for every data scientist, if you are working in an industry, then there should have a knowledge of the deployment part, how we can build an app and we can deploy it in a real-time environment for further consumption. So let's start. So what I am going to do, I will use simple use case to understand the basic of the data science and how we can drive the model, how we can drive the model, and after that, how we can deploy it. So basically, that's why we kept this session name as prediction to production. So suppose if you are predicting anything, then you must have knowledge of making a production out of these use cases. So let's start. I hope everyone is familiar with the concept of IDE. So basically here I am using Anaconda. You can install it in your laptop, whether it is MacBook or whether it is Windows. You can install it. And after installing Anaconda, you will find Jupyter Notebook. So I hope everyone knows how to deal with, how to play with Jupyter Notebooks. So let's use cases. So as we know, if voice is not clear. Okay. Let me know if now voice is clear or not. Please write in comment box. All right. Great. So let's start. Here I am like importing the all necessary library which we are going to use to build the use case. So as we know, we have to import NumPy. So what I am doing, I am importing NumPy as NP, importing pandas as PD. As we know, NumPy and pandas is very powerful package under the Python. So we have to import it first. After that, we will plot some graph. So here I am using Seaborn. I just joined. May I know what is happening? Okay, so Naman, I have just started with the use case. First, those who came late, I will explain everything. So just bear with me. Everything will be clear. Screen is shared, Vijay Lakshmi. Screen is already shared. You can see. Yeah. So guys, let's focus on the use case. So what I will do, I will first, make one model in Jupyter Notebook, and further we will deploy it. You can deploy it on your choice of cloud, but in this scenario, we will test application as a professional API testing tool. So let's start. So here, what I am doing, I'm importing Seaborn, as well as I need matplotlib. So I am importing it as well as PLT. As we know, these are the aliases for this particular package. So further we can use SNS, PD, or NumPy as NP. So let's start. I'm executing this. Okay, so we have imported all of our required model. Now what we will do in further stage of the use case, there will be one step where we have to divide our data set into training set and test set. For that, what we have done, we have imported sklearn model selection train test split. By using this particular object, we will split the training and testing set. Okay, here case, check your audio access. Okay, all right. So what we will do, we will further split the train and test set. So first of all, what I will do, I will load the data set. Basically, I will read the data set using PD, pandas. So I am using pd.read_csv and I am loading diabetes.csv. Now this data set will be available on Kaggle. You can download it. Though after this session, I will share the code on my GitHub repo. So you can download it from here, there itself. So there will be data as well as all the codes which required to set up these environments. So I will definitely upload it there. You can download it after the session. So no need to worry. Please just focus on what is going here. Okay. So here I am basically loading the data into data frame. So now I can check df.shape. So there is 768 rows and 9 columns. Okay. So let's look what is in the data. So here I am, I have written df.head. So here you can see based on the certain conditions, basically based on the certain diagnosis report, there is an outcome, whether the person is diabetic or not. So it's a case of classification. We have to classify that whether the person, based on these diagnosis report, whether the person have diabetes or not. So for diabetes, it is 1, and for suppose if a person have no diabetes, then the outcome is 0. Okay, so here you can see there is 9 columns. Now what I am doing, I am writing df.info. What it will give me? It will give me the name of the column as well as non-null values, as well as data type associated with these columns. So we have 768 non-null values and the data type of each of the columns. Here you can also see that there is 768 entries. So basically 768 entry is rows present in the data set. If I go to this particular directory, let me go to that directory, and in documents, demo, here you can see we have a diabetes dataset. I have loaded it in our notebook. Okay. Yes, this is the data. So here you can see the pregnancy, glucose level of the person, blood pressure of the person, skin thickness, insulin level, BMI. These all are the diagnosis report for particular person, the age of the person and outcome. Suppose if these are the diagnosis report, then the person have outcome as 1. So it means this particular person have diabetes and this particular person don't have diabetes. Okay. So let's go to the Jupyter notebook. Now, for in every machine learning use case, first, as we know, we will have to start with the exploratory data analysis. That's why I am doing exploratory data analysis. So basically I am finding out what is in the data, how it is, how the distribution is, how the outcome is lies, whether there is any inconsistency in the data, whether the null values present in the data. So all we will check. So by looking at this information, there is no null values in the data. So we are enough to go ahead. Now, what is the predictor in our case? Predictor is nothing but outcome. So we have to predict these values, outcomes. So what I will do, I will check whether this outcome resembles any, data imbalance properties. So what I will do, I will, yes, outcome, yes, Deepak, outcome is dependent column, variables, please go a bit faster. Yeah, let's draw cont plot. So what I am using, sns.contplot, x is the outcome, and I will give data as df. Okay. So here you can see we have ample amount of zero as, so basically the data is issues in the data using distribution plot. So basically I am drawing KDE means kernel density estimation. So here you can see the maximum age lies in between 20 to 70. There is some outliers. Here you can see there is some outliers, but here our aim is to not looking into much more into exploratory data analysis. We have our main aim for this session is to deploy our machine learning model. So let's start. As you know, we have to check for correlation as well. So here I am checking the correlation between these columns, that is independent variable. So here I have draw one heat map that tell you how positively or how negatively they are correlated with each other. So suppose if two column is highly correlated with each other, then we can drop one column. So in this particular case, we can drop, either insulin as well as skin thickness. You can see horizontally insulin and skin thickness. So it is similar kind of, it is highly correlated. So we can drop among those two. We can keep one. For now, what I am doing, I am keeping all the features. I will not go with, what correlation matrix is saying, what heat map is saying. Okay, I will go with the all columns because our aim goal is to deliver our app. So let's start. Here I am doing one more thing, that I am trying to plot the age with the BMI. Okay, so here you can see we have beautiful SNS graph of box plot where I have given on x-axis, you can see we have age, and on y-axis there is a BMI. And here you can see some data pointers is there. So these all are outliers. This can be a homework for you, that you can try to remove these outliers. I will not remove for this use case because it's not necessary. Okay, I will go with the outlier as well to train the model. So let's see. Now what we will do, we will separate dependent variable as well as independent variable. So what we will do, In X, I will keep all independent variable. And how we can do that? We can do by dropping outcomes. So let's go to this particular df.head. These all are the independent variable, and these are this outcome is the dependent variable. So what I will do, I will make these all columns as X, and this column, this particular predictor as Y. Yeah. Here we are using box plot for distribution, as well as we can use it as outlier detection as well. Yes, you can use scatter plot for outliers as well. Okay. It's up to you whether you are using box plot or whether you are using scatter plot. We can use both to find outliers. Okay. So let's go ahead. From sklearn model selection, import train test split. So I have already imported it, so there is no need to import again. I'm commenting it out. Here you can see I'm using this train test split. I'm giving X as a first parameter that contains independent variable, and Y is dependent variable. Here we are going with the size is equal to 0.3. That is 70-30 ratio. It means that we are dividing the data into two parts. One is training part and one is testing part, and random state is 101. So here you can play with these parameters to achieve more accuracy. Now what I will do, I will import logistic regression, as our main goal is to deploy the model. So I am using simple logistic regression. So I have logistic regression with me. Now what I will do, I will log model dot fit X train and Y train. Here we have divided our data set into training and test, and I am fitting it into the logistic regression model, which comes from sklearn library. Very simple. Okay. Now here you can see I am calling predict function. So basically our model is trained in this line, and now we are going to predict it. So what I will do, I will give X test as an input, and I will get the prediction for that. Okay. Hi Pranesh, you will get these all codes on my GitHub page, GitHub repo, so no need to worry about it. So here what I am doing, I am giving the test set into prediction function, and now it's giving me the overall all predicted value against the testing value. Now what we can do, we can evaluate our logistic regression model, how it is performing, whether it's performing well or it's performing poor. So it is a important part in any machine learning life cycle. So what I will do, I will again import sklearn metrics, import classification report. Now I am printing classification report. Here you can see accuracy we achieved is 79%. It's around 79%. Here you can see recall, F1 score, support. if you want to know about these all metrics, you can simply search Google and find the meaning. So meaning of the these all terminology, what it resemble, what like you can understand by these particular metrics. So let me go to a confusion matrix. Confusion matrix. Here I'm like uh, here we have a confusion matrix in which you can see our false positive, false negative, true positive, true negative values. Okay, by calculating on this you can also achieve this classification reports. Let's suppose you have to calculate accuracy, then there is a formula for that. Okay, so now I am checking accuracy. So here you can see accuracy is 79%. We can go ahead with the deployment. Precision is 74%. Recall is 0.61%. So metrics looks like fine. But yes, yes, Hansita, you are right. Accuracy is the formula for accuracy should be a true positive plus true negative divided by all the all the parameters. So here you can see accuracy, precision, recalls. So 79% accuracy can be improved. You have to, filter out outliers, as well as you have to do some more feature engineering on this use case. Definitely you will get accuracy more than 79% or maybe 80%. Okay. Here I am drawing accuracy score. Since we have limited time, so I will say that accuracy score, AUC score is nothing but a score which lies in between, 1 represents perfect classifier and 0.5 represents a worthless classifier. So here you can see accuracy score is 0.83% AUC. Here you can see 0.84% this time we are getting. So it's fine to go with, deployment of this particular use case. So what I will do now, the main, the main practical applications starts from here. These codes you can find anywhere on Google, but after that, like you will struggle that how we can deploy it. So let's start with the main, main area of this webinar. So main aim of this webinar, I can say. So let's see, we have one library, joblib. So by joblib, what you can do, you can compress your model. You have trained your model here, log model. So see, log model, we have trained the model by using fitting the X train and Y train. So now we have trained model in log model. What we will do, we will compress this log model to our directory. It can be any cloud location. It can be any cloud location as well. So for simplicity, what I am doing, can we use pickle to store the classification model? Yes, yes, Abdul. This is pickle file only. Joblib is saving it in a pickle file only. Yes, Arun, you are right. Internally, it is pickling. Yes. So here what I am doing, I am dumping it to our location. It can be your laptop. It can be your cloud location. Yeah, pickle file can be used. Yes, pickling is serializing. Okay, so now our model is saved. Let's Now our model is saved. Let's go to the directory. Here you are seeing that log underscore model dot diabetes underscore prediction. Name can be anything. You can give my model. Okay, so model name can be anything. Here you can see my model is generated. So basically this is nothing but a pickle file, compressed file. If you don't know pickle file, then we can say this is compressed file. We will use it further for make a application. Here you can see application is there. So I am coming to that. So now our model is saved. Our model is saved into the compressed format. Now we can use this model to predict our, predict our values, our future values. All right. So let's go to the app. And also let me brief you about this particular folder structure. So here I have prediction to production, in which you will get diabetes.csv, the original data set, the logistic regression notebook. You can use it and you can play around it to generate a pickle file. Also, if you are using Windows, then you have to give extension to it. So you can rename it or you can directly write here dot pickle like this. Okay, so here I am using MacBook, so I need not to give the extension. Okay. Also, if you have doubt after this session, you can ask me on LinkedIn, LinkedIn DM if you are facing any issue with this code. So definitely I am going to upload these all files and folders to my GitHub repo. So you can download it, you can practice it, you can play it with. Okay, so let's go. So what I have done, I have saved my model into the pickle format. There is some other advanced package format as well. You can compress it using joblib, as well as you can compress it in pickle.pv file, .tf file. There are numerous ways by which you can store this model. If suppose you are dealing with TensorFlow, then it can be the .pv file. You can store .tf file as a trained model. Now let's jump to app. So in app, you can see we have one app.py, and what I will do, I will paste Control-C, Control-V. I'm replacing it. What I have done, for simplicity, I have copied it in app folder. In app, we have trained model and our app.py script. What I will do, I will use this trained model, which is stored in compressed format, which is stored in pickle file. What I will do, I will load it and I will give the input to this app.py. Now let's jump to VS Code. It's VS Code is very popular IDE. You can use it, you can download it and you can use it. So it's a very comfortable to do code with it. So basically, let me explain you what is the difference between some people have a question that why not we are doing it with Jupyter Notebook, why we are using this VS Code. So the answer is that if suppose you are developing an application, not data, not playing with, exploratory data analytics. You are building full-fledged application. Then you need one ID that can be Spider, that can be PyChart, or that can be VS Code. Because see, suppose if I am going with, developing an app, and we are trying, we have to debug it sometimes. So in Jupyter Notebook, there is many complications to debug, any app. But here, debug is very super simple. So you can use any full-fledged IDE like Python, Spider, or maybe VS Code. Here I am using VS Code, Visual Studio Code. You can download it from Google and you can set up it. Okay. So here you can see I have my folder already present. Here you can see my saved model is my_model, Logistic model, and here you can see the notebook. It's already present. Let's go to the app. As I have shown you in the directory, we have in app, we have two files, only two files, app.py and saved model. So now let's look at app.py. Since we have less time, I have a plan that I will write the code in front of you for, app.py, but due to time limitation, we can't do that. So let's jump to the app.py. What is in the app.py? So what I am using here, I am using Flask. So suppose if you have a data science use case and you have saved model, so you have to build a app to host it somewhere, either on the cloud or either on the laptop. Let's talk in the reference of laptop only. So you want to make an app, then you have to, you have the basic idea, you have to gain knowledge of some framework, some popular web-based framework. So in Python, there is multiple web-based framework. First one is Flask. Let me write it here. First one is Flask. Second one is Fast API, you can say. And there are many more. These all are the web framework in Python. So here I have used Flask. You can use, if suppose application is very time critical, then Fast API is the solution, because it's really fast, as name suggests, in comparison to Flask. So if you are like working on any critical application, time critical application, then you should go with the Flask API. Otherwise, for normal application, you can use Flask. In this session, we will look at how it's easy to write Flask API. So what I am doing, see, here we have only 43 line of code. I will explain it to make you understand that how it's working. Okay. So what I am doing, I wrote a Flask API to expose the endpoint of this trend model, Here you can see we have app.py, we have saved model. So now what we will do? We will write a Flask API. And how we can write a Flask API? First of all, what is Flask API or what is Flask? Flask is a framework you can say Flask is a framework in Python. And suppose if you want to build a web app, then you can use it. So again, what I am doing, I'm importing some libraries, importing NumPy as NP, importing Pandas as PD. The all library which you have used here in your Jupyter notebook, all library will work into your Flask API because it's based on Python. So there is no hiccups and there is no package mismatch, version mismatch. Flask is very much compatible with your data science packages. That is one more reason to use Flask here. Okay, so let's start with Flask. What I have done, I have imported 2-3 new packages which may like new to you because you are seeing like first time. So here I am importing from Flask, import request. And suppose if you don't have Flask, then what you can do, you can open an integrated terminal. Suppose if you don't have Flask, what you can do, you can install pip install Flask. So I have already Flask installed in my environment, my Anaconda, as well as on my this particular IDE, particular IDE. So Flask version is 2.0.1. I'm using 2.0.1. So like Flask is already satisfied. Let me clear it. Okay. So you have to install Flask package, and after that you can use it freely. So let's jump to next line of code. From Flask, import Flask and JSONify. We will use JSONify. I will explain you why I am using JSONify. Again, for building pipeline, we are importing it sklearn.pipeline import transformer mix transformer and as well as make pipeline. Okay, I will let you explain that what it is doing and why I have imported. And definitely we will import job lib. So if you see closely, here I am importing job lib, import job lib, and I am encrypting. I am compressing the file, trained model file using job lib. So suppose if we want to use this particular model in future, then definitely we have to import job lib to decompress this file. That's why I have imported job lib. So first you have to encrypt the model in Jupyter Notebook, and you have to save the model by any name of your choice. Okay, and suppose this model is saved. Now what I will do, I will decrypt it in our Flask API using job lib, using the same library. So basically I will load this particular model, this particular trained model. Okay, now let's come to the architecture. So here I am importing the library. Now you have to write one line of code, that is the initial starting point of the Flask. So here you can write Flask __ name. This is the syntax. You have to remember it, or you have to like understand that this will be the entry point for our this particular app. So in app, I have given this particular line of code. Now everyone like writes some methods in Python. So here I am writing one method. This is the method, and what this method does, it will predict diabetes predictions. So it will take the input and it will return the predictions. Okay, and here you can see I am hosting this particular app on local host. Suppose if you are using cloud, then you have to give your IP address of the cloud machine. Suppose if you are doing Google Cloud, then there should be one one connection string where you have to give your host name, and you can host it on any cloud. Here I am using port number 5001. You can give port of your choice. So this is the basic structure of Flask. First, you have to import it, all the required library. Then there should be an entry point. Then there should be one method which will do the actual job. And in last, where do you want to host your this application? Whether it's in your local system, whether it's in you want to deploy it on cloud. For cloud, like I have just explained, that you have to replace this local host with the cloud IP address, nothing else. You can try it like in by yourself to host it on any AWS, or maybe on Azure, or a cloud of your choice, maybe on DigitalOcean. You have to just, what you have to do, you have to transfer this file. You have to copy this file app.py and log model diabetes predictions. Okay. Let's go to the chat section. What will be the syntax to deploy on Azure Databricks? Yes, generally when you are using Spring, you use notebooks like Jupyter or Colab. In actual production, you need to use a proper text format file like .py. Yes, Rishikesh. Yes, if you are going with, if you are working for a company, then definitely they will not allow to use Colab or something like that. They have some full-fledged IDE like PyCharm or VS Code, or maybe Spider. Okay. Seaborn and Matplotlib. Great. Please, how did you come up with the diabetes.json file? Yes. I will explain it. I will explain it. Yeah. So let's come to the explanation. So what I am what I was explaining. Yes. What is the syntax for AWS deploying? Syntax will be the same. See, this app.py will be the same for AWS, for Azure, or for any cloud. There is no need to change in app.py. Please keep in mind that there is no special syntax or any special package that will differ when you will deploy it on cloud. So for app.py, it is same for all of the cloud. Basically, you need to change here only on you need to change the host as well as port number, nothing else. You have to give the machine which you are using in Google Cloud or Azure, or the machine you are using on AWS. You need to change the host, nothing else. The rest will be same as it is. You can try it out. And if you have any question on deploying, you can like simply ping me on LinkedIn. I will answer it. I will try to answer it. So no worries. So let's understand the structure of Flask. It's very important. So what I have done, I have imported the library. I have make one entry point. I have make one method. And here I am using one decorator. That is, I think everyone have knowledge about decorator. So basically, I will use this function with the help of this decorator. And as we know, the syntax to write decorator is @app.route, means if any request come to this app.py, then where it will routed to diabetes predictions. And what will be the method? Method will be post. So let's again, I am explaining that suppose if you are using suppose if you are using any professional API testing tool and you want to call this app.py from outside of the world, then you have to make one method which will leverage your model, and give the prediction. So basically what I am doing here, I am routing that particular request which will come from outside to diabetes predictions. And what will be the method? Post. You can write it get method as well. Okay, it depends on you. It can be any method, whether you are trying it with your browser or any software professional API testing tool. So now what I will do, I will request the data. What kind of data I will request? I will request the JSON, request.json. It will request, suppose if any query or any API request hit this particular method using app.route, then definitely we need data to predict. So request.json will accept the data from your from your source. It can be mobile app, it can be web browser, it can be anything. So here I am requesting the data. Yes, please give me the data, or please give me these particular X test. I will predict all the values. So basically here what I am trying to explain you, that here we are requesting the data in this line, request.json. That's why I have imported JSON here, JSONify, as well as JSON related imports. Now what I will do, I will save this data and I will convert this data into data frame. Okay. No worry, it will never run because we are running out of time. Yes. I am trying to wrap this course. So let's see what I will do. I will request the data, I will convert it into data frame, and what I will do, I will make all the I will try to construct all the independent variable in this particular app. So here you can see I am receiving it and I am changing the type. Maybe the type have different, suppose we are requesting here the insulin, and suppose insulin is coming into a string format. So what we have done for precautions, we are converting it into integer, which our model can take. Now what we are doing, we are saving these all input into the test. Now the main aim is to load the model. So here I am using again joblib. You can see here I have imported joblib. So I am loading it, joblib dot load, and loading it in our Flask API. Now our model is loaded. Now what we can do? Our model is now loaded using joblib. What we can do? Model dot predict. Here you can see log model dot predict. Here I am giving X test. So basically I have to give input in similar fashion to get the predictions. So what I am doing, I am giving it using our Flask API. So I have done pre-processing of the incoming request, and I have given it to the model. And what function I am calling model.predict.test. I will get the output. Now what I am doing, I am returning this output to the end user. Here you can see I am writing one text. Your diabetes test is whatever is the prediction. I am concatenating it with the final prediction and storing it in final prediction, and I am returning the final predictions. Now let's go to the demo. Okay, so what I am doing, I am opening it in integrated terminal. What I am doing, I will run it Python app.py. Python app.py. Okay, now you can see that our app is running on localhost 5001. Okay, our app is running on localhost 5001. Now let's directly jump to the conclusion that how we can test it. So our API is ready. Our app.py is ready to host on port number 5001. Suppose if you have deployed it on cloud, then instead of localhost, you can use your cloud address. Okay. Let's come here. What I am using Postman. You can download it, it's free. So you can use it Postman. What I am doing, as we know, in industry, if you want to use any API, then you have to send a JSON request. So what I am doing, see, here you can choose, let's make one new. It's similar to those who is new to Postman. It's similar to your web browser. See, here I am generating one more request. What I will do, since we are using post method, so what I will do, see, now I am using Postman. You can download Postman using Google, and Postman is professional API testing tool. So here you can see we have post method. There is multiple methods. So here we have post method. Why I have chosen post method? Because here I am expecting any request using post only. So I have chosen it post method. Now enter request URL. So what I will do, I will copy this URL. Command C. I will copy this URL, Control V. And so I have copied this URL, and which method I want to use this particular method. So I will copy the name from here. Control V. Diabetes predictions. For demonstrated purpose, someone was asking that please explain about .json. Okay, so let me explain you. For easy reference, I have made the JSON file. Let me diabetes.json. Here what I am sending the data. Which data? The report, the diagnosis report. So here you can see in diagnosis report, I am passing these particular column 1, 2, 3, 4, 5, 6, 7, 8 column. And in our Jupyter notebook, you can see here we have 0, 1, 2, 3, 4, 5, 6, 7. So 7 column. So we will pass these independent variable as a JSON, and we will get the outcome results. So this is the JSON. Here I am coming to body. Sorry, let's come. Here I have built a URL. 1 minute. I have pasted it wrongly. Okay, here I am going to body. The URL is already ready. We are using post method, and I will go to body. And in body, what I will do, I will go to raw. I will choose JSON, and I will control all. This is a sample input, nothing else. This is a sample input. I will give it to model. So here you can see I have given all the 7 independent variable, and I am hitting it. See, now I am getting your diabetes test is 0. So basically, what is the flow? From this postman, I am sending the request to app.py. So basically, it will hit this machine, whether it can be a cloud machine or it can be AWS machine, GCP machine. It can be anything. No need to change or change the syntax or something like that. It will be as simple as that. You have to specify your IP address with the port number and your methods. So basically, I am sending the input response, and it is giving me your diabetes test is 0. So when I am clicking send, what it is doing, it is coming to this particular app.py. It is executing this method, and as we know, we are sending this data. So we are giving this data. Here you can see we are giving this data to the model, and model is predicting it. Okay, model is predicting it. Here you can see the response we are getting every time is 200. That means the API request is successful. Here I am changing the output. Let's say this time if anyone diagnosed with the high level of glucose, so it is a 189, then definitely that person have diabetes. So let's send this input and see the results. Your diabetes test is 1. So hence we have built a, I can say, autonomous diagnosis tool or diagnosis AI system that can help to predict whether you are diabetic or not based on your diagnosis report. So in this app, what we have learned that how we can build an API. We can build an API. We can build a machine learning app that can be able to predict whether you are diabetic or not based on your diagnosis report. Okay. At the moment I am hitting the URL, it is sending me the request. Request. Now please, I think I have explained due to time limitation, I have skipped some portion. Definitely I have skipped some portion. Now you can ask me question. Yes, guys, we are open to questions. I know we have exceeded our time limit. Yes, the API can be exposed to be used by a third party. Yes, completely. Lucky we can expose it to third party.
Excuse me. Before we proceed to answer your questions, I would like to request the attendees to please fill the poll about feedback as it helps us to conduct more such sessions.
Okay.
Please continue.
Yes, Bharat Obray, you can check this particular my GitHub page where I will upload it by tonight. You will be able to access by tomorrow. Very good insight. Thanks for it. Thanks, Lucky. Thanks. Nabila is the same same structure for most AI system. Yes, like it depends on how your organization is delivering the architecture. There might be a different architecture, but Flask can be written as it is. That's why I have focused on what is the structure of Flask. Ganesh Mishram, very informative session it was. Thank you, Ganesh. Rahul, thank you. Deepak, yes, Deepak, I will upload it on GitHub page. You can access that repo. Everything will be available right from Jupyter Notebook, trend model, as well as app.py. Sujay Paul, thank you guys. So thank you. Bharat Kumar, thanks for great demos. Thank you. Anyone have any question? Please let me know, or else we are running out of time. You can ask me on LinkedIn DM. I will try to answer any question like questions from you. Kirlin, thanks. Sailendra, thanks. Yes, I think yes, please share your GitHub page. Yes, I am sending you Rajan Yadav. Yes, yes. You can go ahead and connect with me on LinkedIn. I will share it. May you upload one using Fast API. Okay, I will do that. I will try to do that. We'll look forward to attending more of your session. Okay, Joseph, thank you. Thanks for your kind words. I will try to make like one more session with analytics Vidhya. Yeah.
Thanks a lot, Rajan Yadav, on behalf of Analytics Vidhya. I would like to thank you for your time and for delivering such a wonderful session.
Yeah. Thanks. Thank you. Thank you, Analytics Vidhya team. Okay. Bye-bye, guys.